on the other side, what would this value be then? 2.999, 2.99, and 2.9. And once again, I would, let's go ahead and put this in y equals. Please make sure you're using parentheses, because otherwise you're not going to get the correct graph. So x squared minus 9 divided by x minus 3. And then in my table set, I already set up the table, so I can type in what I want. Now I'm going to type in these values. Or you are more than welcome to just plug them in for x, but that's going to take more time. Do you see at 3 there's an error now? Because it's not defined at 3. Okay, now let's jot down our values. I'm going to just put a little dash there because it doesn't exist. Okay. Now, can you see what the limit is? Well, first of all, does it have a limit? Does it approach one number from the left and the right? 6. Do you see it doesn't ever get there? But if I got closer and closer and closer, the function would continue to get closer to 6. Okay? And so what we're going to do then is we're going to write down, here it is. The limit is 6. Even though I can't find the actual value at 3, it does have a limit. It gets closer to that. And I'm going to just show you a second. So interesting, I just graphed this. This, which doesn't look like a line, when it pulls up on the graph, it is actually a line, right? But watch what happens when I try to put in 3. Do you see how it's undefined? So this is actually a line that has a hole in the graph at 3. But we can still find its limit because it's approaching the same value. Does that make sense so far? Okay. Let me just then show you a picture of a graph, or a couple pictures of a graph, and just show you some things that have limits. Okay, so sometimes in a graph we're going to have a hole like this. We'll call it, and that's at point x equals c. First of all, could you find f of c? Do you know what, if I plugged in c in whatever it was, let's say it was 2 or 3 or whatever, could I find it? No, because there's a hole in the graph, right? Yeah. However, looking at the graph, it still has a limit. We would call its limit L. Let's say that again, we'll just draw a fake xy axis, and I'll call this value L. Okay. So, still has a limit, but this f of c I'm going to write is not defined. Okay, let me draw a similar picture. I'm going to draw the same thing. I'm going to draw a hole in the graph, okay? And then I am going to fill in that hole up here. Now, just because I put this value in, that does not change the limit at all, because what's the definition of a limit? What it approaches from both sides, correct? So I'm going to draw my fake xy axis again. L is right here. The limit of this is still L. It doesn't matter that that's up there, because that's not what the definition of a limit is. The definition is if it's zooming into one value, and it is. They are approaching these values Just because I filled in the dot doesn't mean that that makes it the limit. So f of c is defined, but not the limit. So this, I'll call this c again. This limit is still this y value, or L. When we get into the algebraic stuff, this is going to be like a piecewise function. Like you're going to see a function for this part, and then they're going to give you a value for that part. And then the last one, let's try to draw a picture again, same thing. And I'm going to, this time, I'm going to fill in the hole, okay? If the defined value is the same as what they approach, then it is the limit. So I'm going to say f of c is defined and is the limit. Okay, so I want to point out in all three of these cases, these all had limits, but there were different things going on at that point C. So all three of those things had limits. Okay.